All right, this is Mr. Wyrick. I'm going to be going through some of these sections of the review with you. Remember, you probably won't get the exact same questions that I have, and you can hear my dog destroying a plastic bottle in the background because this is life at my house. Okay, so on the constructing a perpendicular bisector, we're going to start with the compass. We drag out somewhere past halfway. We mark that arc in. We don't resize. We just put this on the other end point, and then I'm going to make in that same arc, and I'm going to put a line that connects my intersection to my intersection. Once I have that done, it's all good. I have it. Then on the slopes of parallel and perpendicular lines, I need to solve this for y, but I don't need to pay attention to the other stuff that's on there. I just need to look at what's going to happen when y is equal. I would subtract 12x, that's a negative 12. Then I would divide by 2, that's a negative 6. So this is going to have a slope of negative 6. It wants parallel, so the answer is negative 6. Okay? If it had been perpendicular, something like this, I would subtract the 2x, so I have negative 2. I divide it by 2, that's negative 1. I take the negative 1 over 1 and I flip it, so it's still negative 1 over 1. And then I change the sign. This would have a slope of positive 1. We need a better perpendicular probably. Okay, on this one we have negative 6, and this is just it. So my slope is negative 6. That would be negative 6 over 1. I would flip it and I would change the sign. So the opposite reciprocal would be a positive 1 over 6. Okay, you're going to have 2 questions on this on the test. One will be parallel, one will be perpendicular if I set it up correctly. The equation of the perpendicular bisector, we struggled with this just a little bit. The first thing I need to do here is find the slope of this line. So I have 7, 4, and I have 9, or negative 9, negative 4. I do change in y over change in x. I'm doing this over here. 4 to negative 4 is a change of minus 8. 7 to negative 9 is a change of minus 16. So this is a negative 8 over a negative 16. Change in y over change in x. That's going to reduce down to a positive 1/2. So that's the slope of this segment. I'm looking for the perpendicular bisector. So I need the perpendicular slope here. I flip this, I change the sign. That's a negative 2 over 1 or just a negative 2. So I know it's going to be y is equal to negative 2x, right? But I'm going to use the y minus y1 is equal to m times x minus x1 point slope form. And I'm going to find the midpoint of these. Well, to find the midpoint, I just add them together and divide by 2. 4 plus negative 4 is 0, divided by 2 is 0. So my this is my y value, that's going to be 0. And then 7 plus a negative 9 is negative 2, divided by 2 is a negative 1, so my x value is going to be a negative 1. So my slope is negative 2. I've got y minus 0. I probably wouldn't have to write that in, but I will anyway, is equal to m, my slope, which is negative 2. And instead of saying minus a negative 1, I'm going to say x plus 1. I go ahead and put that in. That's y minus 0 is equal to negative 2, parentheses, x plus 1, close my parentheses, and we are good. You can put it in point slope form. I'll leave point slope form on the board for the test probably. Okay, the interior and exterior triangle angles, this gives me J, K, L. They're all interior angles. They're going to add up to 180. That's 4, 5, 6, 7, 8, 9, 10, 11, 12, 18, 17, 16, 15, 14, 13, 12. So 180 plus 12 is 192. 192 divided by 12 is, I lost track already. But it's just asking for the value of x. You should be fine. You just set them all equal to 180, combine the like terms, and solve. Okay? Then you'll get one like this. HJ is extended through point J to point K. You might want to draw the picture here. K is going to be the one that's outside the triangle. So if you remember these, we did these before. This is like H, I, J, and then K is out here. Okay, so you get IJK. That's my exterior angle. It's going to be equal to these two remote angles. So this would be 6x plus 3 out here. And then the other two, JHI and HIJ, it's x plus 5 and 2x plus 13. Those are going to add together to equal that exterior angle, okay? And then be careful here too, because it's asking me for the angle, not that x value. So I do still have to solve this to get the x value, but then, see, this is JHI. I need to put that x value into this one to get my answer for the measure of JHI. Okay, then properties of isosceles triangles. For the most part, it's either going to tell you what the isosceles triangle, how it matches up, or it's going to show you. So I'll just draw this over here real quick. It's NOP, and it says that OP is congruent to NO, which would mean this angle and this angle, sorry, OP is congruent to NO, so this angle and this angle down here are going to be the same. It gives me angle O, 57. That's the one that's by itself. So I would do 180 minus 57, and whatever I get, because it's this third angle, I'm going to divide that by 2 because angle N and angle P would be the same. There are a few problem types on this one. Sometimes it gives you the angle that is one of the isosceles. Sometimes it gives you a side that's one of the isosceles. You just have to pay attention to what it's doing, okay? The CPCTC, this says that this triangle is congruent to this triangle, okay? You're just looking at the statement. Measure N is 117. What's the measure of T? Well, we have the middle one here. We have the middle one here for Y. That's not it. So I cannot determine that answer based on what they gave me. On this one, though, I have this statement. I have F and I have W. So this is 77 and 37. I can add those together. That should be 114. And all the angles of a triangle have to add up to 180. So this can be determined. And if I have 180 and I subtract 114, that's going to be 66 for that missing angle. Okay, the triangle congruence criteria. This is where we had the angle, side, angle, 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 side, 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 hypotenuse, leg. I know I'm forgetting one. I just can't remember what it is right now. Okay, but this one is angle, side, side. There's no donkeys in geometry. This one does not work. Okay, if all we have is angles, we remember that does not work. But most of the time on these, and I think I gave you a couple, it should be fine. This one, notice that the side is not touching both of the angles that they gave me. So this should be angle, angle, side. So this is angle, angle, side, and it does work. Make sure to check back on the notes. Oh, I didn't fill that one in. That could be a problem. There we go. Make sure to check back on the notes if you need a refresher on which one of those is good. Proving triangles similar, same kind of thing. We look at what we've got. We have this 60, we have a 60 here, so we have a congruent angle. 12 times 3 makes 36. 14 times 3 does make 42. So these triangles are similar. We have the two sides with the angle between, so it's side, angle, side, but it's the sides are proportionate and the angle is congruent. Not that all of them are congruent, because that would be congruent triangles, not similar. Okay, on ones like this, I have two angles. That's good enough. You may have to do some subtraction on some of them if it gives you angles and doesn't give you the same ones to see if that third one does match up. Okay, the equivalent proportions and similar triangles. This is the one, there's no numbers. It gives you statements up here. So it's either going to give you little over big, or it's going to give you big over little, or it's going to do like this one did. This is the weird one. It gives you two sides of the single triangle, okay? It gives me IJ and JK. Well, I can just look at my statement, IJ and JK. IJ is the first two letters. So over here, the first two letters are FG. Then JK, that's the second and third letter. The second and third letter over here is GH. Okay. And again, some people did struggle with this one. I'll try to look at another. No, that's the same as what we had before. Okay, so on this one, I have EF over HF. I have the big triangle over the little triangle. And I had a lot of people just try to like flip this and be like, that's the same one. 1 over 3 or 3 over 1 is not the same as 1 over 3. So I can't say that that's an equivalent, that's not an equivalent fraction here. That's not the same ratio. All I need to do is pick another side from my big triangle. I'm going to go with DF. And then I pick that same side on my small triangle, which should be GF. And it's going to say, hooray, you did a good job. Okay, then the last one, word problems. And the word problems can seem a little difficult at times, but really you just need to set it up as little triangle over big triangle equals little triangle over big triangle. And then we'll cross multiply, we'll solve. Nearest hundredth is going to be 2 decimal places. You need to watch out for, I think I took this one off so you wouldn't have to do Pythagorean theorem. I think it's the tree one, if I can find the tree. There's the tree. This 24.2 that they give you is not the small triangle. This is just the distance from the big triangle to the small triangle. So we need to take 29.05 minus the 24.2 to get this long side of my small triangle. Then it would be little triangle over big triangle equals little triangle over X on that big triangle, the height of that tree. Okay, so hopefully that gets you everything that you need. If you have any questions, I'll open it up for last minute questions before I give you the passcode on the test. And good luck and study hard.